Hello everyone, welcome to my YouTube channel Concept Clear. In today's class, we will see today we will study about Hamming code in the subject of computer networks. What is Hamming code? Hamming code is nothing but one of the error detection code. Okay, one of the error detection code that can be used to detect the errors as well as the correct those errors. Okay, Hamming code is the only technique will be performs error detection as well as the error correction. Okay, that can occur when data is moved or stored from the sender to receiver. Okay, here Hamming code is a error detection as well as the correction technique. Okay, for example, here we are taking a M is a message, any number of bits. Okay, any number of bits, the sender, sorry, the size of the bits is 4 bits, so I am tracking here the 4 bits are 1010. Okay, the sender sending these 4 bits with a parity bits, so parity bits are the receiver. Okay, what is the parity bits? Okay, this is the original, this is the frame, this is the 4 bits we are sending the message. Okay, what is the parity bits, and we have to find out the what are the parity bits. Okay, how to find out the parity bits means this is the formula for finding the parity bits. What is the formula here? 2 power r greater than or equals to m plus r plus 1. Okay, so here we have to check the r value. Let's check with r equals to 1, then the formula equals to 2 power 1 greater than or equals to 4 plus 1 plus 1, so that total is 2 power greater than or equals to 6, so the condition is false. Okay, so r equals to 2 means again the condition is false. Again r equals to 3 means the condition is greater than or equals to, the condition is satisfied. So condition is satisfied means r equals to 3. R equals to 3 means we have to add 3 parity bits. We have to add 3 parity bits. So the sender will add 3 parity bits to the original message. Send it to the receiver. Okay, here parity bit will be depends on the size of the message. Okay, here what is the size? M equals to 4. So we can simply blindly can tell that m minus 1 parity bits. Okay, this is the procedure. We have to find out the number of parities, but this is the direct way to find out the number of parities. Okay, now we have got the parity size. Now parity will be added at what positions? Manaki, we know the what is the number of parity bits. Okay, in which position I have to add means now I have to check 2 powers 0 positions. 2 power 0 means, that means 2 power 0, 2 power 1, 2 power 2. Okay, how many bits? 3 bits, so 2 power 0, 2 power 1, 2 power 2. So what are the positions? 2 power 0 means 1, 2 power 1 2 means 2, 2 power 2 means 4. Okay, now so the total size of the matrix is 4 original bits are 1 0 1 0, 3 parity bits are. So what are the total positions here? The positions of the parity bits are 2 power 0 is 1 first position, 2 power 1 means second position, 2 power 2 means 4th positions. Okay, these are the positions of the parity bits. Okay, so what are the positions here? I am writing here the positions are 1 2 3 4 5 6 7. So what is the parity bits we have to write? What is the first position? Parity is of P1, parity bit 1. What is the second position is parity 2. And what about the third position is? The third position, you don't know the position value, so I have to write the original frame bit 0. And fourth position is, here we have to place the fourth position parity bit, so fourth is the P3 parity bit, and remaining 5 is fifth position, 6th 7th position is the original bits. Okay, now we need to find out what are the parity bits of P1 P2 values. Okay, first we have to find out the number of parity bits we have to add. After that, after finding the number of parity bits, we find out the what is the position of the parity bits. Now we have to find out the what is the parity bit value. So what is the parity bits values are P1 P2 P3. So how to calculate the parity bits value? The parity bits is 2 power 3 means how many combinations we will get? Generally we will get 2 power 3 means 8 combinations. So we have to write total number of bits are 8. So these are the bits will be start from 0 to 7. So here this is the decimal, this is the BCD code, decimal code. So in BCD code, what is the first parity bit? P1 column, P2 column, P3 column. Okay, you have to write the BCD code decimal value. 0 means according to 8, 4, 2, 1. 0 means what? 0, 0, 0. Okay, if it is 3 means only 3. Okay, this is equal to 0. So write 0 means 0. And what about 1 means? 1 is 1, 0, 0. So 0, 1, 0, 0, 1. Okay, like that we have completed all the positions. So now what is the positions? The positions are 1, 2, 3, 4, 5, 6, 7. The positions are P1, P2, 0, P3, 1, 0, 1. Now we have to check even parity. When we have to check for even parity for the P1 column, P2 column, P3 column. We have to check the even parity for P1 column, P2 column, P3 column. Okay, here first P1 column. In P1, how many ones we have? In P1 column, we have 1, 2, 3, 4 ones. 4 ones means that is the even parity. If it is even parity, no need to add any ones value. So it is the 4 ones means we have to write the 0. Sorry, it is the P1. We have to now what are the positions we have to P? What have the positions of the first position, third position, fifth position, seventh position. So it is 1, 3, 5, 7. Like that we have to write the P2 number of ones the way their positions, P3 number of ones in their positions. Now we have to find out the P1 value. What is the P1 value? In P1 value, how many ones? In P1 value you have 4 ones. So 4 1 means how many values is required to convert maintain as the even parity. 4 1 is the even parity, so no need to add the any value. So P1 equals to 0. P1 equals to 0. So what is the parity bit for this here? 0. 0 is the parity. So P1 value equals to 0. Okay, and what is the P2 value? Here again P2, what is the position is 2, 3, 6, 7. Okay, what is the P2 value is how many ones here in P2? In P2 the number of ones are 1, 2, 3, 4. So how many ones in P2? Sorry, what is the P2 bit here? The P2 bit is P2 position is P2 position is 1. Okay, here P2 is the P2. What is the P2 position value here? The P2 position value is 0. P2 value is 0. P3 value, P2 in P2 column, P3 is third position is 1, and sixth position is 1, and seventh position is 1. Okay, according to that, now we have to check what is the P2 value in this one, P2 0, 0, 1. To convert these values and to make them these values, and how many ones we have to add? We have to add the 1. So 1 value is added. 1 is added means what? P2 value equals to 1. Now what is the P3 column? P3 column 4, 5, 6, 7. What is the P3 fourth value is? In P3 value is, what is the P3 value is? P3. P5 value is 1. P6 value is 0. P7 value is 1. Okay, here also we have to write the P1 position is 1, P1, so P1. P3 is 0, 0. P5 is here, fifth position is 1, so 1. P7 this is 1, so like that we have to write this all the positions. Now we have to check these three. How many values we have to add to get the even parity? Here P1 0, 1, 1. So how many values we required? Ones. How many ones we required? No ones. So 0 is added. So what is the P1 value is 0. Here also is the later we are added. So what is the number of ones here? 1. So to become is 1. This is a even parity. How many ones we have to add? 1. So 1 is added. So P2 value is 1. P3 equals to P3, 5 is 1, 6 is 0, 7 is 1. So P3 1, 0, 1. So what is the how many parities, how many ones we required here? We required 0 1, so we are adding 0. So what is the P3 is 0. So now the sender sends this 7 message, 7 frames, 7 bits as a from sender to receiver. What is the frame? 1 0. Check here. Is the positions. P3 value we know 0, P4 is, P2 is 1, P1 is 0. So I will write this. Now the sender message. This is the frame sent from sender to receiver. What about the receiver side? At the receiver side, it calculates the parity bits. It calculates the parity bits. What is the parity bits? In P1 positions 1 3 5 7. So again he will write the 0 0 1 0. Okay, here according to this one, P1 is 0, P3 is 0, sorry, P3 is 0, P5 is 1, P7 is 1. So okay, like this, P2 is 2 3 1 0, 6 is 0, 7 is 1, P3 is equal to 4 5 6 7. P3 means 4 5 6 7. 4 1 is 0, 5th one is 1, 6th one is 0, 7th one is 1. Now how many parities is required for P1 to make them as a even parity? Okay, here it requires how many ones we have? Already have 2 ones. 2 ones means what? It is already even parity. No need to add that one. So it is 0. The even here parity is 0 is the parity. And what about here? The number of ones is 2. So what is the value we require to make them as a even parity? No 0. No need of 1. So it is the 0. And what is the P3 is also 2 ones means we require the number of ones are 0. So 0. So now compare this. All the 3 parities are zeros. Then you can say there is no error is occurred. Okay, if the parity bits all are the zeros, we can say that no error is occurred. Okay, then there is no error is occurred in the message. For example, instead of 1, here we are taking the 0 value. The taking the 0 value means what? At the receiver side, he will find out the P1 positions are P3 1 5 7. P1 means 0, here 0, here 0, here 1. So to add these values, how many ones we require? 1 1. So parity is 1. So here parity is 1. So here also same. P2 is 1, P2 is 2 ante 2 place lo 1, 3 means 0, 4 6 means 0, 7 means 1. Okay, what about P3? In P3, 4 5 6 7. 4 is 0, 5 is 0, 6 is 0, 7 is 1. So what is that? How many parities is required here? How many ones is required here? Here no need of adding any ones, so 0. And how about here? To make them as a even parity, we required 1. So 1 is added. So now check all the ones are how many? All the ones, all the parity bits are 1 0 1. So it is error detected. So 101 receiver knows that the some bits are modified. Okay, this is about the Hamming code in the subject of computer networks. If you have any doubts, please ask me in comment section. Okay, and subscribe our YouTube channel. Thank you everyone.